Hey everyone, welcome back to the lesson on gravity on an inclined plane. And we're just going to jump straight into example number 2 just to finish off this lesson. So a 72 kilogram box is sliding down a 15 degree incline, accelerating at a rate of 0.70 meters per second squared. So we want to know, what is the coefficient of friction? So there's a couple things we need to talk about this example here. So first off, this one here is different from the first example because now we are not told that we have a frictionless plane. In the first one, it said it was frictionless. In this example, this has no mention of a frictionless plane, which means that we have a little bit more work than what we would had to have done in the, say, the first example. The second part, which is actually related to the first part, is when we talk about this coefficient of friction. So hopefully that should at the very least sound familiar to our very first lesson on the 4 different types of motion. But your coefficient of friction is a variable, or it's a constant value that is related to finding the frictional force. So if we're looking at the frictional force equation, the coefficient of friction was this coefficient, or this variable mu, and in order to find your frictional force, we had to multiply that with your normal force. Okay? So ultimately what we're going to do is we need to find this value, this coefficient mu, which means that we need to know both the normal force and that frictional force of this object. So as always, I am going to start off by drawing just a quick diagram of this situation. So I'm going to start by drawing my incline, which we can just draw as a right triangle. And we know that the incline is 15 degrees, and we would just assume it's from the horizontal, which is this angle down here. Next, we can draw the 72 kilogram box, which is sliding here at the top of this incline, and it's going to be sliding on down. Okay. So as I had mentioned, we need to find this frictional force, and we need to find this normal force. So basically with any type of these questions, we are always going to be working with some type of force, and the easiest one and the first step that is going to be for almost every single one of these types of questions is finding this gravitational force that is pulling this box straight down. Okay, so this first step here is we're going to find that gravitational force. I'll call this one here F of G. So to find your gravitational force that's acting on this object, that is using the equation your mass times your acceleration due to gravity. The mass of the box, as stated in the question, was 72, and your acceleration due to gravity, as we know on Earth, is 9.81. So if you plug it into your calculator, we should find that we get 706.32. Once again, I am going to keep track of my sig figs here. So here we're only really concerned about the values given for our mass, which here has 2 sig figs, meaning our answer also has to have 2 sig figs there as well. So I'm just going to underline that just to keep track of it. Okay, so now what we can do is we can use this gravitational force, and we can use that to find another piece of information. So our ultimate goal is we're trying to work towards this frictional force or the normal force. And so we can find actually this normal force. If you guys recall from the first lesson, our normal force is the force that's acting in the up direction on the object. And in this case here, it is in terms of the surface. So this one here is going to be kind of acting like this. This is your normal force. That right there does not create a very nice looking triangle that we can really work with any of that. But what we do know is that if we were to find that gravitational force that's acting perpendicular to the surface, this value right here, this gravitational force, and I will call this number 2, that's acting perpendicular to the surface, is equal to that normal force. So here I'll say this. So your gravitational force that is perpendicular, or I call this force of gravity number 2, is equal to your normal force. So just to explain that just a little bit more, so with your gravitational force and that normal force, remember, if there was an imbalance, that means that this object would either be moving off, like maybe up into the air, or it would be moving into the surface. But this one here is just following along with the surface. It's not actually moving off of it or kind of digging its way into the incline. So we know that these two forces are equal. So if we find this gravitational force that is perpendicular to the surface, then we know what our normal force is. So once again, we can create that right triangle, and using our alternate interior angles property that we learned in that video, we know that this angle right in here is 15 degrees. So we have the hypotenuse of this triangle, we have an angle, and we have the adjacent, which means that in order to find this value right here, we need to use the cosine ratio. I'll write step number 2 up here. So here we'll be finding that second gravitational force or that perpendicular gravitational force. So I'll start off by writing my cosine ratio. So that is your adjacent over your hypotenuse. And I'm going to fill in my information. So I know my angle is 15 degrees. The adjacent is what I don't know, which we can label that as x. And then our hypotenuse is that force that we found here, which was 706.32. So in order to solve for x, I'm going to start off by writing cosine of 15 degrees over 1, so I can cross multiply to solve. So if you put in cosine of 15 degrees times 706.32, we should find that you get a rounded value of 682.25. So this value here is equal to this gravitational force number 2, or that perpendicular gravitational force. So step number 3, if you want to make this an official step, is we can just kind of restate that we have found our normal force. So that normal force is equal to that second gravitational force, or that perpendicular gravitational force. So your normal force is equal to that 682.25. And I apologize, I did jump the gun. I forgot to keep track of my sig figs. So just kind of jumping back to this answer here, we had 2 sig figs in our value here for our force, meaning our answer also has to have 2 sig figs. So I'm just going to underline the 8 here. Apologies for that. Alright, so now we have the normal force. This is what we're looking for. So now we need to find this frictional force. So if you guys remember, for your frictional force, that is the force that is kind of, it's almost like a pushback, a resistance against the object moving. So it's going to be moving in this direction right here. So it's going to be slowing down the box and preventing it from moving faster as compared to if it were a frictionless surface. Okay, so in order to find this frictional force, this is where things get a little bit tricky, so make sure you guys are, follow along with what's going on here. In order to find this normal force, where's my pen? Right here. This one here wasn't too bad because we know that the normal force and that gravitational force, these two were equal. But in order to find our frictional force, we know that this frictional force and the force that's pushing it down this incline, they are not equal. And that's because this box is moving down. So that force that's pushing it down, so that applied force, is greater than that frictional force. So I'll say this here. So your applied force, so that's the direction that it's moving, is greater than that frictional force. Okay, so now the question is, okay, well, how do we actually find this frictional force here? And so what we do know is that with our frictional force, we know that the overall force that's happening on this object is equal to your applied force minus your frictional force. So that overall, or your net force, is equal to your applied force minus that frictional force. So if we could find our net force and the applied force, well, then we can just plug into this equation and solve for this frictional force. So that's exactly what we're going to end up doing. So it doesn't matter which one, if you find your net force or that applied force first, it doesn't matter. Both are going to require some different bits of information. If you want to, since we've been working with this right triangle, we can go ahead and continue working with that, which means that we're going to find this applied force. Okay, so that's going to be the force moving parallel to our surface, and that is going to be this portion of this right triangle here, which I'm going to label as y. So part 4 is let's find this applied force. So looking here, we have this right triangle, we have an angle, we have this gravitational force, which is our hypotenuse, and we have an opposite side. This tells us that we're going to use the sine ratio to solve. So that is your opposite over your hypotenuse. I'm just going to scroll down here. And now I'm just going to plug in my information. So the angle was 15 degrees. The opposite is what I was looking for. And my hypotenuse, as I had seen here, was 706.32. I'll write this over once, so that way I can cross multiply to solve. So if you plug this into your calculator, sine of 15 degrees times 706.32, we will get a value of 182.81, and that's a rounded value as our answer there. And just to keep track of sig figs here, we had 2 sig figs in our gravitational force, and so our answer here should have 2 sig figs here as well. Alright, so now we have this applied force. Now we need to find this net force. So that's going to be our next step. Step number 5. This is a very long question. So now we're going to find our net force. So in order to find our net force, we actually have to go back to the beginning of the question and use a key piece of information that we haven't used yet. So here in the question, it tells us that our box is overall accelerating at a rate of 0.70 meters per second squared. Using this bit of information and knowing its mass, we can find that overall force, or that net force. So using our force equation, that is your mass times your acceleration. The mass of the box was 72, and then that overall acceleration was 0.70. And then plugging that into your calculator, we should find that our net force is about 50.4. And then keeping track of our sig figs here, we have 2 sig figs here, 2 sig figs there, meaning our answer should have 2 sig figs there as well. So now we have our net force, we have our applied force, and now we can find this frictional force. So step number 6. So we're going to plug in our values into our equation. We have our net force is equal to the applied force minus that frictional force. So we had 50.4 as our net force, 182.81 as our applied force, and we're going to subtract that frictional force that we don't know. So now we're just going to treat this like an equation, and we want to get this frictional force by itself, so we want to get rid of this 182.81. So I'm going to subtract it on each side. Okay, and so if we plug that into our calculator, if we go 50.4 minus 182.81, we should get negative 132.41 as our answer. And one thing that's really important here is that we still have the subtract frictional force, so that just becomes negative frictional force. So we don't want to find this negative value, so what we need to do is we need to multiply both sides of our equation by -1, and this will get rid of those negatives. So we have an answer for our frictional force of 132.41 as our value. Okay, and I am unfortunately getting to my 50-minute mark, so I'm going to pick this up in the next video. It's sadly going to be like a 3-minute video. We were so close to being done. Sad face.